Welcome and thank you for joining. In this video, we'll discuss one of the most useful arithmetic concepts in all sciences, logarithms. Understanding them is very important in understanding many scientific ideas. And before we get started, I'm going to ask you to grab your calculator because we're going to use it to evaluate different expressions that contain logarithms. So logarithm, or as we call it for short log, is just another name for exponent. So we all know that if we have a number 3, we raise it to the power of 2, so that is the base 3 to the exponent 2 or power 2, then the answer would be equal to 9. So this is what we call an exponential statement. And if we were to read this exponential mathematical statement using words, then we're going to say that number 2, the number 2 is the exponent that we must raise the base of 3 in order to obtain number 9. Now, we're going to read the same statement, but instead of the word exponent, we're going to use the word logarithm. So we're going to say number 2 is, so same thing, the exponent. So now we're not going to say exponent, we're going to say logarithm. We must raise the base 3, so same statement, in order to obtain number 9. Now, as you can see, these two statements will describe the exact same relationship that exists between numbers 3, 2, and 9. But now we're going to rewrite this statement here into mathematical equation. So we're going to say that number 2, so we're going to write number 2 is, well, in mathematics means equals the logarithm. So for short, we're going to write log. We must raise the base 3, so we're going to write number 3 at the bottom or at the base of the word log in order to obtain number 9. So number 9 will go inside the log. Now, the two statements describe the same relationship that exists between this exact same numbers 3, 2, and 9, but in different ways. So 3 to the power of 2 equals 9 is what we call an exponential statement, and 2 equals log with base 3 of 9 is what we call a logarithmic statement. Now, to evaluate logarithmic numbers, we use a calculator. So this is a logarithmic number, right, whose value is 2. Now, I want you to find the log button on your calculator. And in some calculators, you will see that when you press the log button on the screen, you will probably have two boxes next to log. And one of them is going to be at the bottom. That's where you can input the specific base that you have in here. For example, then we would put number 3. And right here, you're going to put the number 9, and you can press either equal or enter or answer, so whatever option your calculator gives you in order to get the value of it. And I want you to try to do that and see if you get the number 2. Now, in many calculators, you probably won't see like the two boxes that allow you to input the number at the base and the number inside the log, but you will probably see just the word log on the screen. So when you see just the word log on the screen, it means that you just have to input whatever number you have that you want to find the log of, and automatically you would know that the base is 10. So when the base is not written, so if you have log with base 10 of a number or log of a number, it means the exact same thing. Now, when the base is 10, we don't write it, and that is by agreement. And I want you to think of it the same way as we have worked with radicals. So when we have square root, we do not write the index, but when you have a cubic root, this is when we start writing the index. So the same thing in here. So normally when the base is 10, we don't write it, but what it means is that now if you want to find log with base 3 of 9, which is more specific, we use what we call the change of base formula. And that means that that would be log with base 10 of 9 over log with base 10 of 3, or simply log of 9 over log of 3. So try it on your calculator and see if you get the answer equal to 2. Now, when we solve using logarithms, And I brought in here two examples, 2 to the power x equals 8 and 3 to the power of x equals 8. And we can solve it in multiple ways. So if you have 2 to the power of x equals 8, we can rewrite number 8 as an exponential number with the same base 2. And you can say that since the bases are equal and the two exponential numbers are equal, it means that their exponents must be equal as well. And you equate the exponents, and that would be the answer. Now, another way of solving this equation would be by using logs. So we're going to say that x is the exponent, or should I say log, right? We have to raise the base of 2, so the base 2 goes at the bottom, in order to obtain number 8. And that would be simply log of 8 divided by log of 2. Try it on your calculator and see what you get. You should get the same answer, the number 3. Now, in some calculators, you have to also be cautious of bad maths because the calculators don't automatically, at least not all of them, recognize the bad maths. And to ensure that you get the correct answer, keep the two numbers in brackets so that after calculating the log of 8, then the calculator will divide by log of 2, whatever the answer is. So when we write log of 8 over log of 2, we basically have log with base 10 of 8 over log with base 10 of 2, which is equivalent to log with base 2 of 8 according to this particular formula. So I'm going to rewrite this in a more generic form. So if we have log with base b of some number, I'll call the number a, then we're going to rewrite this as log of a. Oops, that wasn't supposed to happen. So you're going to write this as log of a over log of b, and you can give these logs any base of your choice. But normally in our basic calculators, we are going to use a base of 10 because that's what the log function in our calculator is equipped with. Now, if you have 3 to the power of x equals 8, in the other hand, if you try to follow the same process as we did in here to write the number 8 with the base 3, you see that that is not possible. So in this case, our only way to solve it is by converting the exponential statement into logarithmic statement. So in this case, then we're going to say that x would be, so x is, so is means equals, the log with base of 3 in order to obtain number 8. So that would be basically equal to log of 8 divided by log of 3. And again, the calculator will recognize the base of 10 in here. But again, we don't have to write number 10, and we don't want to overload our equations and our steps with unnecessary symbols or numbers. So if you divide log of 10 by log of 3, I need to grab my calculator. And here we go. Then we're going to see that the log of 8 divided by log of 3 would be equal to 1.89. And I'm going to stop here for a second. It is very, very important to round the log or the answers that we get from using logs to 2 or more decimal places, and that is because these numbers are very powerful because they represent powers or exponents, and a slight change in this number can actually alter the solution. So you have a set of exercises in here that you can try on your own, and I encourage you to try them on your own. I'm just going to do a couple of them together here. So we have 5 to the power of x equals 0.2. So we're going to say that x is the exponent or the log we must give to base 5 in order to obtain 0.2. And that would be equal to log of 0.2 divided by log of 5. Now, log of 0.2 is over log of 5. That would be equal to -1, as a matter of fact. And I know this because it is very easy to do this mentally. It's a simple exponential equation. 0.2 is actually equal to a 1 over 5. And 1 over 5 can be written as 5 to the negative 1. So that's how you would solve it as an exponent. And from here, you can see that x is equal to negative 1. So next question, you can solve it by using the exponents. So 121 is 11 squared. That will make x equal to 2. Now we're going to move on to the next question. You have 4 to the power of x equals 1. You can write it as 4 to the power of 0, the number 1, and that will make x equal to 0. Now, next we have 3 to the power of x equals 7. Now, in this case, you cannot make this with base 3, so you're going to convert this to a logarithmic statement. So we're going to say this is the log with base 3 of number 7. So that is log 7 divided by log 3. So use your calculator for it. I'm going to use my calculator here on the side. And I have log of 7 divided by log of 3. I got 1.77. All right. So we're going to change up the questions slightly here. So in this case, we have 3x in the exponent. So we're going to say 3x is the exponent that we must give to base 6 to obtain number 10. So you want to isolate x from number 3, which means that we have to divide by 3 or multiply by 1 over 3. It's the same thing. And I will multiply by 1 over 3 both sides. And that would allow me to simplify the coefficient and get just x on this case is equal to 1 over 3 multiplying log of 10 over log of 6. So remember that you have to use the calculator in correct order. I would prefer to find the value of the log expression. It's easier that way. And I would start with log of 10, which, by the way, you will probably notice that it is equal to 1, but we'll talk about it at another video when we talk about the properties of logarithms. So log of 10 divided by log of 6, and then divide the answer by 3, and I got 0.43 in this case. So try it with your calculator and see if you get the same answer. Okay, so now moving on to the next example. It's very similar to what we just did. So we have 6x equals log with base 5 of 68. And when you practice frequently enough, so you will notice that you won't even want to write this step. So you can simply write log of 68 over log of 5, and skipping this step is totally fine. And now we are going to get rid of that 6 in there by multiplying by 1/6, and then we'll get x equals. And in this case, actually, again, I'm repeating myself, I would evaluate this chunk of the number in here because it's a little bit more complex. So log of 68 divided by log of 5, and then divide the answer by 6. And in this case, I got 0.44. 0.44. Now, let's continue with another example. You have 2 to the times 7 to the power of x. Now, in this case, we have x in the power, right, in the exponent, but we also have a coefficient in front of this exponential number. So first, we need to get rid of this coefficient. So, and that can be easily done by dividing both sides by 2. So we need to have simply the exponential number in order to convert to logarithmic form. So 44 divided by 2, that would be equal to 22. And now we can convert to exponential statement. So x equals the log with base 7 of 22. And it's very easy to kind of remember this because just think of it as if you are drawing a line here, divide log 22 by 7, and x will be equal to log 22 over log of 7. Simplify. Evaluate, 22 divided by log of 7, and I got 1.57. 1.59 in this case, so it's 1.588. Now let's move on to the next example, very similar to what we just did, but a bit of fancier numbers in this case. So we'll divide by 100 both sides, and that is because x is actually the exponent of this base. So we want the exponent and the base to be all on its own before we convert to logarithmic statement. And now we have 1.002 to the power of x is equal to 1000 over 100. So this is super easy. I see a lot of people using the calculator for it, but you don't have to, and you know it. Why? So here we go. We have x is or equals the exponent or the log that we must give the base of 1.002 in order to obtain number 10. And that would be log of 10 divided by log of 1.002. And we have 1 divided by log of 1.002. And there we go. We got a negative number in this case. Let me just double check. Oh, I pressed, that made no sense. That's why I was wondering. So let me just, I pressed the wrong button here, 1.002. And we got actually quite a large number, 1.1152. And we're going to have x here equal to 1152.44. 1152.44. Okay, so moving on to the next set of questions. You see that you have questions similar to what we just did. So you have questions where you can convert the other side into exponential form and the ones where you cannot. And this is when you have to use the examples that we just went through in order to practice on your own. And I hope that you enjoyed this lesson and you found it easy. It is kind of easy and it's a little bit entertaining in my opinion. And thank you for learning with me. Bye for now.